7.1, systems of linear equations, two variables. So how do we handle this? So it's two equations with two letters, two equations with two unknowns, and they want us to solve for x and for y. So how do we do it? Well, there's basically two different methods. This problem is telling us to do it by the substitution method. The substitution method is where you plug one equation in for another, like a substitute teacher plugs in, takes the place of the regular teacher. It's a substitution method. Notice the two equations, 5x plus 2y equals negative 29, and y equals negative 4x minus 25. So especially notice that second equation. It says y equals negative 4x minus 25. That means y is the same as negative 4x minus 25. So that means I can take that y and plug it in for y in the other equation, because y, that second equation says that y equals negative 4x minus 25. So that means wherever I see y, I'm free to replace it with negative 4x minus 25 because it's equal to negative 4x minus 25. It's the same as negative 4x minus 25. So where does that leave us? 5x plus 2y, and I'm going to plug in for y now. What am I going to plug in for y? This right here, negative 4x minus 25, because that's what y is. All right, plug this in right there in the place of y. Okay, so what does that give me in my equation? 5x plus, and then this 2 is going to distribute, negative 8x minus 50 is negative 29. So 5x minus 8x, combined like terms, that's minus 3x. They combine to make. Solving for, now you see how that gets me down to only one letter. Now my only letter is x, and I can solve for x. So add 50 to both of these, and we get negative 3x is, what is that, 21? And then divide by negative 3, x is negative 7. So we got x, it's negative 7. Now how do we get the answer for y? So now we plug in x equals negative 7. You can plug that in anywhere you want, but the easiest place, since you want to get y now, would be to grab this y equation. It says y equals negative 4x minus 25. Take that negative 7, plug it in. So I grab the one where y is already alone since I'm looking for y. So negative 4 times negative 7 minus 25, that's what? Plus 28 minus 25. So y is 3. So here's the answer. Negative 7, comma 3. They want you to put it in parentheses. There, that's x, that's y. It's always x first, then y. By the way, you could check that answer and prove it's true. Let me show you. If you put in negative 7 for x here, and negative 7 for x there, and 3 for y here, and 3 for y there, right? Because x is negative 7, y is 3. It'll make all those equations true. Let's see it. 5 times negative 7, that's negative 35, plus 2 times 3 plus 6. Negative 35 plus 6, if you check it on your calculator, is indeed minus 29. Makes that equation true. Second one, 3y, 3 equals negative 4 times negative 7, that's plus, two negatives make plus 28, minus 25, that's 3, sure enough. See how negative 3, 7, x negative 3, y, x negative 7, y 3 makes both equations true at the same time. It solves the whole system. So that's our answer. Let's do number 2. We're going to have to go to a fresh screen where we have some room. So number 2 says 7x minus 3y is negative 61, and 2x plus y is negative 10. Okay, so same deal. We're wanting to solve by the substitution method, but this time it's a little more tricky. We don't have an x or y alone. See how this last problem, go back to number 1, we already had y alone in the second equation. Y equals negative 4x minus 25. Y was already alone. So that was easy. Well, in this one, y or x, neither one's alone. So what you could do is first get x or y alone in one equation, then plug into the other equation. So the easiest place, let me write it, easiest is x or y with a 1 in front, positive 1 in the front. That would be the easiest place. So that's going to be this right here. This y has a nothing in front, which means it's got a positive 1 in the front. So that's going to be the easiest one to start with that equation. So I'll start there, get the x or y alone in one of the equations, and the easiest one is an x or y with a 1 in the front. So I'm going to take this equation, bring it up here for a minute. 2x plus y is negative 10. And I'm going to just subtract the 2x from both sides. Boom. So y equals minus 10 minus 2x. So it was easy to get y alone. I didn't have to divide by a number in front of y, which would make fractions. So I take that now. That came out of the second equation, then plug that into the other equation. Plug that in right there for y, because that's what y equals. Plug that in for y in the other equation. So here we go with that. I'll bring it down here. We have 7x minus 3 times y, and y is negative 10 minus 2x. Whoops. Equals minus 61. So I just took this top equation, but I plugged in for y what I found for y in the second equation. So now let me just distribute. 7x plus 30 plus 6x minus 61. 7x and 6x is what? 13x plus 30 is minus 61. Subtract 30 from both sides. 13x is minus, was that 91? That's a plain old 30 there. And then last step, divide by 13. X is minus 7. So we got x, and now what do you do to get y? Remember, we just go back. So we got x right here. And then you plug in x is minus 7. Where? Well, the easiest place would be where y is alone, right here. I mean, you could do one of these two equations here, one of the original two equations, but you could really plug in anywhere you want. It'll work, and this is the easiest place. Y equals minus 10 minus 2x. Why is that the easiest place? Well, because y is already alone there. Y, what I'm looking for, is already alone. So we get y is minus 10 minus 2 times minus 7. Y is minus 10 plus 14. Y is 4. There we go. The answer is minus 7, comma 4, x, comma y. They want the two numbers with the parentheses and the comma in between, x, comma y. There we go. Let's go to number 3 here. So on number 3, they're wanting me to solve these two equations, again, by substitution. So remember what you do first. First, get x or y alone in one equation, and then second, plug into the other equation. So, okay, going to get x or y alone in one of the equations. So, and the easiest is 1x or 1y. So that'd be right here, 1x right there. So take that equation. X plus 3y is 27. And subtract 3y from both sides. Boom. So x is 27 minus 3. So we got x alone. Get x or y alone in one equation. That came out of the top equation. So now grab that and plug that in for x in the other equation, in the second equation. So now I'll bring down the second equation down here. So minus 7, I'm going to plug in x right there, plus 4y is minus 14. Plug in the x. What was x? 27 minus 3y. See, that gets an equation with only y now. So now we can distribute. 7 times 27, I'm using my calculator, it's a big number. It's at 189. So minus 189 plus 21y plus 4y is minus 14. Okay, let's keep going. Minus 189. 21y and 24y is 25y is minus 14. Add, trying to solve for y here. Add 189 to both. This cancels. 25y equals, what's this, 175. And so, bring it up here. 25y is 175. Last step, solving for y, divide by 25. And y equals, how many quarters in $1.75? 7, right? So y is 7, we got y, and now we got to plug in. Easiest place, what's it going to be? Right here, we're trying to find x now, right? Just go where x is already alone. It's going to be the easiest place. Plug in that y is 7 right there. 27 minus 3 times 7, 27 minus 21, 6. So the answer, they have it right there. X is 6, y is 7. We got it. 6, 7, x comma y is the answer by substitution. All right, so on to number 4. Now we're going to change methods. There's another method that's also good for solving two equations with two letters. And this one's called the elimination method. It's also called the addition method. It goes by both names. It's the same thing by two different names. So how does it work? How do we do it? Well, we want to add up these two equations. Let me bring them over here. We want to add up these two equations, and well, let's just go right here and add them up. Add them up. It's called the addition method, and have things eliminate. So 6x added to negative 2y is 4x. Plus 2y added to negative y is plus 1y, right? 2 plus 2 minus 1 equals, and 14 minus 4 is 10. So I just added up the x's, added up the y's, added up the numbers, and notice nothing eliminated. I wanted something to eliminate, so that didn't work. I wanted either x to drop out or y to drop out. Because see, here's the deal. We can't solve it while we still have both letters. We need to have either x or y eliminate, so we'll only have one letter, and then we can solve when we only have one letter. So let me go back up here. I better do something to one of these equations to make x or y cancel out. So what am I going to do? So that was just a display of what doesn't work. So that didn't work. So step one, multiply to make the x's or the y's opposites. Meaning, we've got to make these two x numbers be opposites. Like I could make that a plus 6x, and if I multiplied the bottom one by 3, that would make that minus 6x. That would work. Or you could do the y's. You could make the y's be opposites. You could multiply that one by 2, and then it'd be plus 2y and minus 2y. Those would be the opposites. And then add. So step one, so I'll do the 3. Let's multiply through by 3. So I'm going to bring down, now the top equation doesn't change at all. I didn't multiply it by anything, it's good. The bottom equation though, the 3 is going to go boom, boom, boom. I have to multiply the whole equation by 3, right? Whatever you do to one side of an equal sign, you have no choice. You have to do the other side to keep them equal. So I get minus 6x minus 3y, and this is minus 12. That 3 multiplied here, here, and here, that 3 on the outside. Notice how I've made the x's opposites. So now step 2, or I'll just write it over here, then add. So now these x's will cancel. I purposely made them opposites, didn't I, so that they would cancel like that. So now they cancel by design. So that's good. That's what I wanted. I wanted them to cancel. So they will do that. So what's left for the y's? 2y minus 3y is minus 1y. 14 minus 12 is 2. Now I have only one letter, and I can solve for that letter. I can get y alone. Divide both sides by negative 1. Y is positive 2 over negative 1, negative 2. I got y. Now, how do we get x? You know what to do now. Once you get one letter, you just plug back in to get another. So plug in the y equals negative 2. Where? Anywhere you want. The easiest place would be if we had x alone somewhere, but we don't. So I'll just grab the first equation. You could grab the second. It matters not. It'll be about the same either one. Just grab any equation you want, plug in the y value. 6x plus 2 times minus 2 is 14. 6x minus 4 is 14. Add the 4. So 6x is what? 18. And you know how to finish this. Bring it over here. 6x is 18. Divide by 6 on both sides. X is 3. So we got x, we got y. So the answer is 3 comma negative 2, x comma y. There's the answer. We got it. So that was the elimination method. It's also called the addition method. So step 1 is you multiply to make the x's or y's opposites, and then step 2 is you add them together. So I multiplied the bottom equation by 3 to make these guys, the x's, opposites. Then when I added them, they canceled, they eliminated. That's why it's called the addition method. You're adding. It's called the elimination method because you want something to eliminate. Because you can't solve both letters at once. You need to get rid of one of the letters so you can solve for the other letter. We got rid of x. We solved for y. Once we got our y answer, we plugged it in right there and got our x answer. There we go. Let's try that again on number 5. So on number 5, on number 5, the question goes 4x minus 5y is 17. The second one is 3x minus 3y is 12. So we're going to do the elimination method again. So it means we're going to make opposites. So this time we're going to need to multiply both equations. This one's going to be a little more advanced. In other words, let's do the x's again. I could multiply this equation by -3, because -3 times 4 will make that -12, and multiply the bottom by +4, because +4 times 3 will make that +12. So that'll do it. I'm going to make the x's opposites. I could have made the y's opposites. It doesn't matter. But this time I had to multiply both equations rather than just one of the equations like on the last problem. So we get minus 12x plus 15y minus, 51. The second equation is going to be plus 12x. That boom, boom, boom. Right? Boom, boom, boom. This 4 multiplies. Minus 12y and 48. So now we add them. So step 1, multiply to make the x's opposite. Could have done the y's, went with the x's. So that's step 1. Step 2, add them. These cancel. 15y minus 12y is 3y. This comes out minus 3 minus 51 plus 48. It's minus 3. Finish. Now we have only one letter. Now we can solve for y. Divide by 3. Y is -1. We got our hands on y. You know what to do. Once you get one letter, plug it in. Plug in y. Where? I'll just grab the first equation. Doesn't matter that we changed it, multiplied it, whatever. Just grab the original version. Or you could grab the new one. It'll work the same either way. 4x minus 5y is 17. Plug in the y, which is -1. Minus 4x plus 5 is 17. Bring it up here. Finish solving now for x. Subtract 5. Boom. Minus 4x is 12. Last step. Divide by minus 4. X is minus 3. So we got x, we got y. The answer is minus 3 minus 1. X comma y with the parentheses and the comma. Oh, did I make a small mistake over here? I don't know why I made that 4x negative. That 4x should have never been negative. So divide by positive 4. X is positive 3. Sorry about that. That was just a mess up. I don't know why I made that x negative. There we go. Now it's correct. Positive 3, -1. There we go. Okay. Let's try number 6. So on number 6, same kind of question. Solve the system. We got to make opposites. So I'll take it right here. 2x minus 4y is 18. 3x minus 6y is 24. So step 1. Step 1, multiply to make opposites. It can be x or y. I'll do x. So what can I multiply? I'll just multiply here by -3 and the bottom by positive 2. Right? -3 times +2 will make that -6, and +2 times +2 will make that +6x. So I'll make the x's opposites. And so what do I get when I make the x's? So I'm purposely making the x's opposites. I'm not even worried about the y's. You just pick one letter. You could do x's or y's. It doesn't matter. Just pick one letter and make those, multiply both equations to make those opposites. So boom, boom, boom. I get minus 6x plus 12y is minus 54. The bottom equation, boom, boom, boom. Plus 6x minus 12y, 48. Add them up, these x's cancel, and the y's cancel. Look at that. And the other side we get minus 6. That's weird. What does that mean? Notice we wanted the x's to cancel. Step 2, we're adding them. We wanted the x's to cancel. We made the x's opposites on purpose, but accidentally, not really accidentally, but without trying to, we made the y's opposites. Also, when we added them up, all the letters vanished. X and y vanished. What does that mean? When you get 0 plus 0 equals a number that's not 0, when x and y both cancel at the same time, that means no solution. That means there's no answer to this problem, or they want us to say D and E. That stands for does not exist. The answer is D and E does not exist. There's no answer that exists. There's no answer to that problem. So if you get 0 plus 0 equals a number that's not 0, meaning x and y have both canceled, it's no solution. Does not exist. The solution does not exist. There we go. So let's try number 7. Let's put it on a fresh screen over here. So now we go to word problems. So number 7, a bank loaned out a loan of $36,500. Part at 2%. The rest at 14, not 4, but 14%. The rest at 14%. Okay, so the total interest earned for both parts was $3,070. And so the question is, how much was loaned at each rate? How much loaned at 2% and 14%? Okay. Well, how do we do these? This is it's a money problem, and the way you set up these money problems is you have two equations. The first equation is going to be with the percentages. So it's going to be, oh, I'm sorry, the first one is not going to be the percentages. It's just the x is the amount in the first part, y is the amount in the second, and they have to add up to be $36,500, right? Meaning, if I'm letting x be the dollars at 2%, I'm going to let y be the dollars at 14%. So the dollars at 2% plus the dollars at 4% must be the whole $36,500, because the $36,500 part was at 2% and the rest was at 14%. So x plus y must total, the amount put in at 2% plus the amount at 14% must add up to total $36,500. So the second, so basically when you have two letters, you need two equations. So we have two letters here, x and y, x being how many dollars were put in at 2%, and y being how many dollars were put in at 14%. So two letters, you got to have two equations. There's our first equation. They must add up to be a total of $36,500. The second equation brings in the interest, right? However much x is, the interest was 2% of that, so 0.02 times x, and the other one was 14% plus 14 times y. So however many dollars x is times 2% of it, that's the interest on that money, and however many dollars for the y part of the loan at 14% interest for that part of the loan adds up to be a total interest of $3,070. So there's our two equations with two letters. So now we just have to solve. We've learned how to solve two equations with two letters a couple of different ways. We've used both the addition method and the substitution method. So either one's fine. I'm probably just going to take this top equation and I am going to multiply through, get rid of this here, multiply through that top equation by minus 0.02. It's going to go there, there, and there. So I'm just going to make opposites. I'm going to do the elimination method and make these opposites. So I'll get negative 0.02x, negative 0.02y. And use your calculator. Negative 0.02 times 36,500. I'm getting negative 730. And then the second equation, I'll just bring it down. So, the first step is you multiply to make opposites, opposite x's in this case. And then the second step is you add them. Now add them up, and those x's cancel. That's because you made them opposites. 0.14y minus 0.02y is 0.12y. 3070 minus 730. I'm getting 2340. And then finish solving for y there. Divide by 0.12. Divided by 0.12. I'm getting $19,500. So y is $19,500. That's the y part of the loan. Now, remember that the loan total is $36,500. So the other part, the x, must equal the $36,500 minus the $19,500. Right? Because they total $36,500. So there's the x part of the loan. That's $17,000. So the $17,000, the x, is the amount at 2%. So that's the 2%. And the y is the amount at 14%. $19,500 at 14%. There we go. We found the two amounts. Okay, so there we go. Let's go to number 8. The admission fee at an amusement park is $1.25 for children, $6.20 for adults. On a certain day, 275 people entered the park. The admission fees collected totaled, what is that, 1,012. How many children and how many adults were admitted? Okay, well, let's call it C for children plus A for adults. The total number of people that came in was 275. Children plus adults must equal 275. Right? I'm going to use C and A instead of X and Y. It's just easier to identify what they are. So now with two letters, remember you need two equations. So what's the second equation? Well, it's $1.25 for each child. So now we're going to bring in the money. C is the number of children. A is the number of adults. So however many children times $1.25 for each child, plus however many adults times $6.20 for each adult, adds up to be a total of $1,012, doesn't it? You don't need to put the dollar sign in there, but right, that makes sense. However many children came at $1.25 each, plus at $6.20 for each adult, adds up to be $1,012. So there we have our two equations in two letters. The top one is just total number of people. The second one is the money. So let's go to a fresh screen and solve those two equations. So we have, again, children plus adults is 275. And the money for the children, $1.25 for each child, plus 620 for each adult must total $1,012. Okay, so how do we do it? So step one is we multiply to let's make the C's opposites. So that's step one. So I'm going to multiply through here by negative 1.25. It's going to go there, there, and there to make that opposite. So negative 1.25C minus 1.25A is, and now what is negative 1.25 times 275? It is negative 343.75. The second equation, I'll just bring this one down, no changes at all. And now I'm going to add these up. These cancel. And what is 6.20 minus 1.25? This is 495A. Subtract those other ones. I'm getting 668.25. Last step to solve for A. Divide by 4.95. A equals 135. So the number of adults that came that day must be 135. How do you find out children? Well, we know 275 total. So if we take 275 and subtract 135, we get 140. That must be the number of children that came, 140. So there we go. Last problem is a mixture problem. So you need a 35% alcohol solution. That's your goal, what you're trying to come up with. On hand, you have 120 milliliters of a 25% mixture. So you've got a weaker mixture. You got a 25% mixture, but you want to bring it up to a 35% stronger alcohol solution. You also have 50% mixture. So how much of the 50% will you need to add to obtain the desired solution? Get the idea? We have a 25% mixture. We're going to add some 50 until it comes up to be 35%. So how do we do mixture problems? Well, the standard way, I'm just going to do the standard way here. I'll write some beakers, 3 beakers. So the first 2 beakers add up to equal the third beaker, the final product. So then you put the percentages on the bottom. So I'll make this, I'll make them decimals. 0.35%. We're mixing that. Oh, no, wait a minute, hold on. The 35 is our goal, isn't it? So that's over here. This is our goal. What are we trying to produce? A 35% solution by mixing a 0.25 and a 0.50. Does that make sense? We're trying to take this low 0.25, add a higher, stronger 0.50, and the goal, the mix goal, is to get something that comes out sort of between them. The stronger stuff, 50% stuff, and the weaker stuff, 25% stuff, will mix together to produce our goal, which is the 35% solution. Now you put in the top the amount. So in the bottom goes the percentages. In the top goes the amount. So how much of the 25% stuff do we have? Well, it says 120 liters of the 25%. How much of the 50%? Well, that's what we're trying to figure out. That's the question. How much? We'll call that X. And what's going to go here? Well, we'll call that Y. So the 2 blanks, I just call X and Y. Okay, so that's a nice little setup, but where's my equations? The first one comes right across the tops. So right across the tops. meaning 120 plus x must equal y. The amount of stuff coming out of the first beaker plus the amount of stuff in the second, remember the tops are the amounts, equals the amount in the final beaker, right? You're going to dump the stuff from the first beaker plus the second beaker to equal the final product. So the amount of stuff coming out of the first beaker plus the amount out of the second must equal the amount in the mix, right? The goal, the mix, the final beaker must have stuff from the first two added up. And then the second one, the second equation, whoops, that didn't say second. The second equation is all about the percentages. So you multiply these two. So 0.25 times 120. That'll give you the actual amount of alcohol coming out of the first beaker. Why? Because the first beaker is 25% alcohol. So if you take 0.25 of times the 120 milliliters, you'll get the actual amount of alcohol in there. You're taking 25% of the whole thing, right? Because it's 25% alcohol. So 25% of the whole thing, 25% of the 120 plus, multiply these two, 0.50x must equal, multiply these two. So the second is always coming by multiply. This is going to be 0.35y, right? Multiply these two together. Let me bring that down here where there's room. So I multiplied to get that second equation. It comes from multiplying. When you multiply the percentage times the amount of stuff, you get the amount of total solution, you get the amount of alcohol in there. So the amount of alcohol coming out of the first beaker plus the amount of alcohol coming out of the second beaker must equal the amount of alcohol in the final mix. The top equation is just total solution out of the first beaker plus total solution out of the second must be total solution in the final. So there's our two equations. Remember, with two letters, you need two equations. There's our x and our y, two equations. Let's go to a fresh screen where we have room to solve that thing. And the second equation was make sure that's right. Yeah, that's right. We got our equations. Okay, so let's just figure this one out right now in your calculator. 0.25 times that, it's going to be 30. Okay, so you know the deal, right? What do we do? Well, let's just do the substitute. Should we do substitution? Yeah, let's just do substitution. Notice this top one up here. Y equals, I'm going to do substitution. Because y equals 120 plus x. It is 120 plus x. That came out of the first equation. Plug that in for y there to the second equation. And what are you going to get? 30 plus 0.50x equals 0.35 times y. What's y? 120 plus x. All right, so let's crank this out. 30 plus 0.50x. Boom, boom. Use your calculator. 0.35 times 120. I'm getting 42 plus 0.35x. Trying to solve for x here. We have x on opposite sides. So subtract the lower one from both sides. 30 plus 0.15x is 42. Now we're almost there. Subtract 30. Boom. Point 15x is what, 12? Divide by 0.15. So 12 divided by 0.15 is 80. So X is 80. That's the answer. We need 80 milliliters of the 50% solution. That's X. That's what we were looking for. We don't even need Y in this problem. Why not? Well, because if you go back to the question, you'll see they asked how many milliliters of the 50% solution do you need? And in the 50% solution, that was X. So all we want is X on this one. So the answer is 80 milliliters is what's needed. And so there we go.